minutes to promote again probabilistic generative models as an interesting way of looking at some things. So I'm interested in studying brain dynamics, but what I will present here could be applicable to any dynamical system that its unfolding in time might be predictive of some interesting feature. The dynamical features themselves are of interest. So in our case, we say that changes in brain dynamics could be an indicator of future alterations in cognitive behavior. For example, in neurodegeneration. So when somebody presents with neurodegenerative condition, the symptoms, the changes in the brain that led to these symptoms had started some 20 years earlier. So the idea is that the features of the dynamics could be an indicator of these future changes. So very quickly, given the time, the brain is a dynamical system. It's an interesting dynamical system. We model it as coupled oscillators, kind of from an engineering point of view. It's an interesting way of studying it. But the important point that we're interested in is that what we observe reflects some hidden states. And the hidden states are probably configurations of networks that is switching between them. So there is this idea that there is a discrete state, which is the network configuration, that emits the observations that we make. So you kind of think about this as a hidden Markov. Now, the underlying problem is this tension between the level of detail that we represent. So we have data, and we try to make sense of the data. We use statistical models or machine learning models. They are useful because we get some interesting predictions or classifications, etc. But they have no biological underpinning. No, the parameters don't mean anything. On the other hand, we have very detailed biophysical models that are very interesting because they give us something that is truly close to the biology, but inverting them is a nightmare. They're non-linear, non-stationary, etc. So the idea is that probabilistic generative models somewhere kind of a bridge between those two spaces. So the idea is that you have a discrete state. You can kind of, this is the nice thing about probabilistic generative model from a Bayesian point of view, that you can characterize all your assumptions in a very explicit way. So kind of the Bayesian inference is the machinery, and we get observations like this. This is data from Parkinson patients where they are doing nothing. 2 minutes of EEG recording, and the system doesn't know, the hidden Markov or hidden semi-Markov model doesn't know anything about them as patients. There is no classifier, there's no teacher other than the assignation of the disease externally. The machine doesn't know anything about that, and is able to, through the dynamical features, classify them or characterize them. More interesting on the right is that it's able to say which of these patients respond to interventions and which not. Trying to take that concept in a step further, try to make some of these machine learning models more interpretable. We're moving towards the Gaussian processes, or what you might call kind of interpretable Gaussian processes, where the parameters themselves reflect something about the biological underlying process. In this case, the frequency of oscillation or the correlation between the frequencies. I think I've got just the 5 minutes.
Okay, good morning, everyone. My name is Adrián Colomer. I'm ValgrAI postdoc student and research coordinator at CBB Lab. And now I'm going to present you how to boost computer-aided diagnostic system with deep generative learning. So this is the outline. The work I'm going to present is a framework in the gradation of prostate cancer. Nowadays, prostate cancer is one of the most common diseases in men worldwide, and the main diagnostic and prognostic reference to make this diagnosed is Gleason scoring system. Is the Gleason scoring system. So nowadays, pathologists have a lot of workload to diagnose the different tissues, and here artificial intelligence-based computerized diagnostic systems are very relevant. However, there exist some drawbacks. For example, the training process is often confronted with insufficient and unbalanced data sets. For example, here in the prostate cancer issue, the more aggressive grades of cancer are less represented in the clinical data. So for this reason, we propose in our research to build a generative deep learning model able to synthesize patches of any selected Gleason grade score. Okay, and the idea is to use these generated patches to build more robust and reliable computer-aided diagnostic systems. In the figure, you can see the proposed approach in which we introduce a generative adversarial network condition in the generator and the discriminator, and it's trained in a progressive way. The approach was validated using CCAP, a public prostate cancer dataset, and we found that our approach synthesized in a promising way the different grades. Okay, synthesizing the different weights with accuracy. And here we compare our proposed approach with the typical and state-of-the-art generative adversarial models, for example, progressive GAN, conditional GAN, and our proposal minimize the different artifacts and improve the generation using condition grades. After evaluating for clinical experts our approach, we found that the clinicians incorrectly identify on average more or less 20% of the real samples as synthetic, and the 30% of the synthetic images were considered to be real. Additionally, we found that there exists a similar behavior in pathologists diagnosed from real and the synthetic generated images. This confirmed that the generated images coming from all the different grades are very, very promising. After that, of course, we train a computer-aided diagnostic system using or improving the less representative classes, and we obtain better results here in the second column using introducing more synthetic images created for our system. As future lines, we are working now in building a explainable Gleason grading CAD system through a content-based image retrieval approach in order to provide clinicians with a explainable tool. The idea is that they can introduce a query and they can obtain some retrievals of similar cases with the corresponding diagnostic. So this is our current work. Here, if you are interested in going deeper to the works, and thank you so much for your attention.
Buenos días. Mi nombre es Iván Jiménez, soy estudiante postdoctoral en la Fundación ValgrAI, supervisado por la profesora Eva Vallada de la Universidad Politécnica. Y bueno, en este trabajo llamado el transporte no urgente de pacientes, estamos trabajando en colaboración con otros profesores como Juan Alberola, Víctor Sánchez y Ful Villa de la Universidad Politécnica también y José Belenguer de la Universidad de Valencia. En este problema nos enfrentamos a un problema diario que sucede en los sistemas sanitarios o en las empresas que controlan los transportes sanitarios, que es pues, una lista de pacientes que necesitan de un servicio. Estos servicios son o bien transportarse de su domicilio al hospital o viceversa, del hospital a su domicilio, y por diferentes motivos estas personas no pueden transportarse o no tienen la capacidad de hacerlo y por lo tanto necesitan del sistema sanitario para realizar estos servicios. En nuestro problema, una de las características más importantes es lo que se conocen como ventanas temporales o time windows, que son límites temporales dentro de los cuales pues, yo puedo recoger a un paciente en su punto de recogida, que puede ser su domicilio o un hospital, y también una ventana temporal dentro de la cual tengo que entregarlo o dejarlo en el punto de entrega, que sería pues, también o su casa o el hospital. Desde el punto de vista matemático, esto es un problema de optimización, por lo tanto se trata de obtener o de llegar a la mejor solución siguiendo algún criterio como objetivo. En nuestro caso estamos utilizando pues, el tiempo que están las ambulancias en circulación para recoger a estos pacientes, pero en la literatura hay muchos tipos de función objetivo. De hecho, uno de los problemas a la hora de compararse con la literatura es que cada autor utiliza un criterio u otro para decidir qué función es mejor o qué solución es mejor que otra. Por lo tanto, en el problema pues, tendríamos algo parecido a esto. Una serie de los puntos azules representan los diferentes pacientes que tienen, pues, como ya hemos dicho, sus ventanas temporales. En este caso, un centro sanitario, pero que normalmente suelen ser más de uno, porque pues, según la especialidad concreta, o si es un hospital o un ambulatorio, pues son localizaciones diferentes. Tenemos también un depósito del cual parten y al cual acuden al acabar la jornada las diferentes ambulancias o transportes. Tenemos la flota de vehículos, cada vehículo con una capacidad máxima permitida, por lo tanto hay que tener en cuenta que durante la ruta no puede haber más pacientes de los permitidos dentro del vehículo y, como comentábamos, las ventanas temporales. Entonces, nosotros estamos trabajando con este problema en dos puntos, digamos desde dos puntos. El primero, resolver el problema como tal, que sería este. Lo estamos haciendo mediante formulaciones matemáticas, mediante modelos de programación lineal entera, que pues, al tratarse de problemas computacionalmente muy complejos no son lo suficientemente potentes y tenemos que recurrir también a algoritmos metaheurísticos como un GRASP que estamos diseñando para resolver este problema. Y luego, otro punto de vista sobre cómo con este problema como base es, digamos, en un entorno de negociación en el que nosotros representamos a una compañía que gestiona transportes sanitarios. Esta compañía, como hemos dicho, tiene su lista de pacientes que debe atender durante un día, pero hay otras compañías que tienen cada una de ellas su lista de pacientes y una vez nosotros conocemos cuál es la ruta a seguir o la mejor ruta a seguir por nuestra compañía, se abre un periodo de negociación en el que tratamos de intercambiar pacientes de uno en uno, es decir, cada empresa, digamos, descarta uno de los pacientes de su lista y lo intenta intercambiar con otra compañía para así, en general, entre todas las compañías, tratar de alcanzar una solución mejor para todas. ¿Vale? Y pues esto es en lo que estamos trabajando. Muchas gracias.
No sé cómo, no sé cómo poner pantalla completa.
Control L.
Control L.
Hello everyone, I'm Miguel Domingo from the UPB. My work is on applying machine translation to the processing of historical documents. So since this is a very brief talk, I'm only be talking about the motivation and the two tasks I'm mainly working on. So historical documents are an important part of our cultural heritage. However, due to the language characteristics inherent in these documents, they are mostly accessible to scholars. And even then, due to these variations and the way the language evolves through the times, orthography has been changing. Since in the past there were no conventions for writing, and this also supposes a problem from scholars which work mainly on applying natural language processing and things like that for the processing. So the first task I'm going to talk about is language modernization, which, as I was saying, these documents are only accessible to scholars since language has evolved too much and the general audience are not able to comprehend. So what we propose is to generate a new version of the document written in the modern version of the original language. So in this case, if we have a document written in Old English, what we want is to generate an automatic version of the same document written in modern English. Of course, some of the richness of the document, of the language, will be lost, but as I was saying, our goal is only focused on making people able to understand better the content. So far, we have been working on this from different approaches of classical statistical based with phrase-based model and some neural machine translation, mostly using LSTMs and the original transformer, and generating synthetic data, since one of the main problems with historical data is the scarce availability of data usable for training. And right now, what we are doing is using pre-trained large language models to try to cover up for the lack of training data. And we are mainly using multilingual models. Mostly we are starting with MBART and FT5, since they are covering between 50 and 100 different languages. And the other task is spelling normalization. As I was talking at the beginning, in the past there were no writing conventions, and the way of writing the same words changed a lot throughout the periods. So what we are trying is to generate a new version of the document with the orthography changed to be written as it is written in the modern version of the language. So in this case, if we have a fragment in Old Spanish, what we want is to update the spelling to modern Spanish in order to help scholars when they're processing these documents, for example, searching from some keywords, like if they're trying to write caballeros, know how to read it. So we have so far tried different classical MT approaches, mostly based on SMT and MNT with LSNTMs and transformer, and character-based approaches. With so far the best results have been with character-based phrase SMT. And also we have only been working with error-free transcriptions, but the majority of these documents are handwriting manuscripts. So since the field of handwritten text recognition are also facing this problem, right now what we are working is on combining handwritten text recognition and machine translation models in order to improve the generation of modern transcripts. That's all. Thank you.
Hello everyone, my name is Sergio Cebollada from Miguel Hernández University, and I'm going to present my work that is developed through the grant, through the postdoctoral grant. First of all, I will present an introduction to my research lines. After that, I will present the 3 works that I'm developing right now. and I will finish with the publications that have been done since I started with the grant. My research line is focused on mobile robotics, autonomous mobile robotics. Specifically, we are focused on two main tasks, the mapping, which is to create the map of the environment, and on the other hand, the localization task, which is to know the exact position of the robot within the map. So in this case, I'm proposing to use an omnidirectional image, which is an image which covers a field of view of 360 degrees. Here you can see an example of the camera with mounted a hyperbolic mirror, and we are obtaining information around the robot. So additionally, we propose to use artificial intelligence models, such as in this case CNNs, to obtain holistic descriptors. We use these descriptors to create the map and also to solve the localization task. So the first work that I'm working on consists on retrain a model, a well-known CNN in this case, in order to carry out a new task, in this case a room retrieval, and also to use the intermediate layers to obtain holistic descriptors. Since the information that we have obtained during the mapping process, the images are not enough to carry out a retraining, we propose to use a data augmentation technique using visual effects that can be done during the localization task. Here you can see examples like rotation, reflection, blur effect, darkness, brightness, etc. Afterwards, when the model is retrained, we can carry out the new classification task, in this case the room retrieval, and at the same time we can obtain the holistic descriptors that we use for localization. So in this work, we study the importance of each visual effect in order to know how important they are to carry out the data augmentation, and after that to tackle the hierarchical localization task. Right now we are starting to carry out also a study about probabilistic localizations. Until now we have proposed a non-probabilistic method which provides a unique estimation, the most probably one. But now we want to propose a probabilistic method which provides us the probability distribution in a map. So for this, we propose a hierarchical model, which on the left side you can see that we have the map information. We carry out the clustering in order to segment the information regarding the visual information. After that, we have the image we introduce to the new CNN, and we carry out the probabilistic localization only in the most probably area. So we are reducing the cost of the computation. The use of this CNN is twofold. We are using the CNN to know the most probably area, but at the same time we are obtaining a holistic descriptor that we use for the localization task. Regarding this last work, we are, I don't know if it's working. No, there's no internet. Okay. Okay, yeah. We have retrained a YOLO in order to carry out our localization task outdoors. In this case, this is the campus of Miguel Hernández University, and as you can see, the network is able to detect objects that can be done in this kind of scenarios. The idea is, on the one hand, try to create a map using this kind of information, and on the other hand, estimate the trajectory of the dynamic objects. Regarding the publications, we have published in an international conference, Artificial Intelligence, and we have also made a publication in a Neural Computing and Applications journals. And that's all. Thank you so much.
Well, I think I'm the last one before the coffee break, so we'll try to be quick as possible. Well, my name is Carlos Marilora. I'm from the University of Castellón, from the Game Research Group. And since 2015, I've been working on academia and on companies, on projects of feature films of animation, completely Wonder Park and Teddy 3. And on those projects, one of my main tasks was to build tools to assist the creation of these feature films to artists. And when I started my PhD, my thesis, it was kind of a tool like that. It was a 2D game engine that we created by studying the minimal requirements of a game, what an actual game needs to be run. And for that, we used the multi-agent system methodology to create a specification system to define games, and also behavioral specification module or systems to define behaviors with first order logic and predicate logic. And we finished with a reduced set of actions and conditions, and we achieved that 7-year-old kids were able to finish their own games with our model. And now with the ValgrAI grant, we are trying to continue naturally continue this project that we started in the PhD. And we have an environment, we have a multi-agent system that has an environment that we can introduce in the game language to the game itself, and a set of agents that are every element in the scene. Each one of them has an state, and the agents are in a continuous side of the state of the environment and try to react to different states of the environment based on their scripts and their logic that they have achieved. And now the first task that we have done in this postdoc grant is to create a language, a scripted language based on this model of first order logic and predicates, with its syntax and with its with semantics that we have a little glimpse there in the bottom of the slide. And we achieve this just with 4 actions that are the CRUD rules of the CRUD methods of the databases: read, create, delete, read, and modify and update. And just one selection element, that is the if-then-else structure. Right now, we are trying to extend the capabilities or the potential of this system. And the first thing is, I don't know if you have ever seen in YouTube or in whatever place, the content procedural generation that is used to texture, to environments, these kind of things. In this case, we are trying to apply this sense to behaviors, to create continuous and coherent behaviors based on our language in games like an RTS, a real-time strategy, or racing games. And for that, we are using a technique that is called wave function collapse, that is a glimpse of the quantum mechanics, to apply to this kind of content generation. And also, we are trying to extend our 2D prototype of game engine to the 3D version with our custom one, and we are trying to apply this to to actual commercial game engines such as Unity or Unreal. And in fact, we are just achieved that in Unity with our description model in JSON, given a JSON file, we have a kind of a plugin that we can put it into Unity, and with our game description, we can create games in Unity directly without any other modification. And that's it. Thank you very much for your attention, and let's go to the coffee.